So we've actually now done a series of studies where we've looked at the relationship between carbon release and temperature in the southwestern Pacific. And certainly what we've seen when we just go as far back as the last glacial maximum, the last ice age, is that there's evidence for quite a dramatic amount of warming on the order of perhaps 8 to 10 degrees Fahrenheit, which is actually larger than what most climate models predict, and certainly larger than what most geologists had previously thought. We've been using a new thermodynamically based tool to constrain past temperature change, and so you'll see this work coming out in the next couple of months. We've also worked in deep geologic time, looking at the climate record, again from sediment cores, but going back to this massive carbon emission about 55 million years ago, which has been deemed by some geoscientists to be the closest geological analog we have for anthropogenic climate change. And what we saw then was actually a similar magnitude of temperature change, quite a large temperature change in response to this carbon emission. Now, in another set of studies, we've looked at the relationship between temperature and past CO2 levels going back the last 20 million years. And what we saw in that study has been verified more recently with other tools. And the conclusion we've drawn, we think, is quite robust. That's to say that the last time there's evidence for CO2 levels being as high as what they are today, about 400 parts per million. If those levels are sustained for fairly long intervals, then what we see is actually there was no summertime sea ice. There's evidence for dramatically reduced ice storage in both hemispheres. So this is the Pliocene interval that was mentioned earlier.
Can we even guess over what time scale we might see the changes that you described in terms of ice sheets and sea level, etc.?
Right. So the type of time scale for changes in temperature we might see, we're going to see an initial response of warming that's quite dramatic. In fact, we were already seeing temperatures responding to the greenhouse gas emissions that have occurred over the last century and a half. So as these greenhouse gas emissions continue, we're going to continue seeing temperatures respond. But there are other components of the Earth system that take a little bit longer to respond. For example, ice sheets. There's probably going to be a time lag on the order of several centuries, let's say, just because of the dynamics of ice growth and retreat. So we might expect that there's going to be quite a strong climate response, but we're not going to see it, probably not in our lifetimes fully, but perhaps in our grandkids and great-grandkids and their kids' generation. Unfortunately, at that point, it's going to be too severe of a response to do anything about. We're already seeing signs from the type of work that glaciologists like Richard Alley and others are doing for the signs of such a response to come. We're already seeing that glaciers are melting at a much more rapid rate than we might have expected in the high latitudes. And in fact, tropical glaciers are retreating at a much more rapid rate as well. So all the signs are there that what we see evidence for in the geologic record is in fact occurring and going to continue to occur. It's just a question of time.